Hi, everyone, and welcome to our Constellation Crew presentation this evening. I'm Dana Thompson, the director of the Brown Planetarium at Ball State University, and I'm here with the rest of the Constellation Crew, or a part of it anyway. We have Nicolette here. Hi, Nicolette.
Hi.
And Caleb. Hi, Caleb.
Hey.
And we have Ricky. Hi, Ricky.
Hey.
And we also have Melanie hanging out with you all in the chat. So if you have any questions for Melanie, go ahead and put them in the chat and we will get them answered. And if you have any answers to our questions during the presentation, go ahead and put that in the chat too. Hopefully we can get a little bit of back and forth with you all watching today. So today we are seeing the sky not tonight in Muncie after sunset, but tomorrow night. And tomorrow is, of course, Halloween. And we really want to be able to show you some cool things that you can take a little bit of a break on Halloween to go out and see. And one of those is our background here. So we always have our constellation of the week that we're focusing on in the background. If you've tuned in before, we have our star pattern hanging out in the background. And it just, is one more cue to letting you know what constellation we're focusing on. And this week, can you tell what we're focusing on by looking at those squiggly lines behind us? Because, unless you know your constellations really well, this one's kind of a hard one. It's hard to find in the sky, but we're going to give you some cues to help you find it, and we're going to see what else is kind of hiding in that area of the sky that you can see with the help of really good telescopes and some other cool things on maybe campus tomorrow evening or just outside where you're at. So the constellation that we are exploring, those squiggly lines behind us, is the constellation Perseus. Some people might have heard of Perseus because of the Perseid meteor shower, which you can see, I think, what is it, guys, gals here, is it in August? I think it peaks in August.
Yeah, I think it's around that time.
Yeah.
Yeah.
So we have these meteor showers. There's one called the Perseids because all the meteors seem to kind of come from the location of Perseus in the sky. So you might have heard of this one, but it's a little bit harder to find that constellation. And Ricky's going to help us find it in the sky. It's actually visible on your screen right now in the northeast after sunset tomorrow evening here in Muncie. But before we do, there's something else that is pretty familiar to everyone in our sky. Tomorrow night after sunset, we have the moon. And what phase is the moon tomorrow, everyone? Do you know what phase it's in?
It'll be full.
Yep, full.
It's a full moon, yeah. So it's a full moon. That means it looks like a big circle in the sky. We know that it's more than just a circle. It's 3 dimensions. It's a round or rounded shaped object out in space. It's a natural satellite going around our planet Earth. But it looks like a big circle in the sky tomorrow night. It is our full moon. And it is the second full moon in the month, which some people refer to as the monthly blue moon or a monthly blue moon. Crew here, have you heard of the phrase once in a blue moon?
Yeah.
Yep.
Use it.
Yep.
And do you actually use it, Nicolette?
Yes, I do. All the time.
Wow. I don't think I've ever used it seriously in my life, but I hear other people use it. And what does it mean? What does that phrase mean?
It's kind of like a rarity. So once in a blue moon, I wake up before 12 o'clock in the afternoon.
That's lucky.
That's a good one.
So it's meant to be like, it's a rarity thing. It doesn't happen often.
Yeah.
It's a funny way of saying it that way instead of saying it's a rarity.
Yeah, so once in a blue moon. It doesn't happen really often. And it kind of makes sense that a monthly blue moon is happening. Well, it's kind of makes sense once you know what a monthly blue moon is, okay? Because they don't happen really often either. So we have a full moon on the 31st of October, and we also had a full moon on Friday the 2nd of October. So we had 2 full moons in one calendar month, which doesn't happen very often. So how how long does it take in between 2 full moons?
Oh, well, it's about 28 days, roughly.
Yeah, 28 days.
Yeah, it takes about like 28 days, 29 and a half or so, to kind of make one full cycle or one full cycle in its phases, because the moon isn't always full. Sometimes we see it as half a circle in the sky. Sometimes we see it as a crescent shape or a gibbous shape in the sky. But it takes about 29 and a half days or so to come back to the full moon phase after being in the previous full moon phase. And so that doesn't always lie in the same calendar month. So it's pretty rare for it to happen. But there's actually an official definition of what a blue moon is from the 1800s that says that the blue moon is the third full moon in a season that has 4 full moons. So what does that mean? So in an astronomical season, so in between the equinox and the solstice, or solstice and equinox, so in about 3 months, there are 4 full moons in 3 months. So it's saying that the blue moon is the third out of the 4 in that rare occasion. So in any case, a blue moon is just really rare. Once in a blue moon, doesn't happen too often. However, it is happening tomorrow night. If you go outside and check it out, if it's not cloudy anyway, you can see the blue moon, a full moon, second full moon in October. So what color should they look for, crew?
Regular?
Right.
I would say like a yellowish orange moon, maybe. That's usually what appears in the fall.
It
But
does
it's
look a
harvest
little
moon?
kind of yellow-orange when it's close to the horizon where the sky meets the ground, kind of like how sunrises and sunsets are kind of orangish. And I'm smiling because Dan, watching here, is saying that he's going to call it the boo moon rather than the blue moon.
Yes.
In honor of Halloween here. I like it. So the boo moon is maybe going to be kind of red when it's low in the sky by the horizon, but when it gets up higher, it's just going to look kind of like how it is looking on our screen here, kind of grayish white. It's not going to be blue. That's the whole point, right? All right, so moving on from the full moon, which you will see tomorrow after sunset, if the weather's nice, that is. You can also maybe pick out some star patterns that we've explored before. And Ricky, help us find the constellation by helping us first find what we explored last week.
Well, yeah, so the way I actually like to find Cassiopeia is what we did last week, is to just point straight northeast and to just stack, I think it's about 4.5 fists on top of each other, and that'll get you straight to Cassiopeia at tonight from what we're looking at, because it's always around the same height. And then right now it's going to be at 3. And then from there you can find Perseus by taking the 3 stars at the bottom of this 3 and kind of following that downwards to one of the brightest stars in here, Mirfak. And then that's going to be the middle of Perseus. And the star directly next to it is going to be the star Algol, and then that makes up the body of Perseus.
All right, so we find Cassiopeia first. This W, usually you hear it being called a W in the sky, but here it looks like a 3. And if you kind of follow the 2 stars here down in the northeast, you can see a bright star here. What's that called again?
Mirfak.
Mirfak, and then Alcor? No.
Algol.
Algol. I knew that. We were just talking. I talked about it all day, actually. I had a meeting about it. Anyway, Algol here. Because that's a really interesting variable star, and I had a meeting with the variable astronomy astronomers, star astronomers. Anyway, words are hard today, but let's see what that group of stars is like here. There it is. All right, so we have Perseus there. It kind of looks like a spiderish type shape, so kind of good for for Halloween here. But you know, what is this actually like? What is Perseus? So if you have a great imagination, you can maybe see all of this with the sword here, and he even has a head with snakes coming out of it as hair, which some of you might already be familiar with. So we have Perseus here, which was a person. So when we see constellations in the sky, sometimes they're objects, sometimes they're even places, but this is a person here. All right, so what's his story? Here's another depiction of Perseus. What's his story, Nicolette?
Well, let me first off by saying that for those who do know, Perseus is the one who decapitated Medusa, which I need to preface that Medusa had a really bad story, and I feel really bad for her. Everyone automatically assumes she's the villain and did all these terrible, evil things. But actually, she was immortal, and she was very beautiful, and she was condemned to look like this. And as you see in the picture, you see kind of a really zombie-like face with the snake in her hair by Athena for having relations with Poseidon, who is another god. And Athena was so upset that she punished Medusa to make her look like that, gave her the snake hair and the creepy face and all that stuff. But back to Perseus. He lived in an island with his mother, Danae, and a fisherman who is not his father. His father is Zeus. His mother is still Danae. There was a king who was after his mother and wanted to talk to her and all these things. And Perseus was not happy about that, but the king really wanted to be with Danae. So the king proclaimed that he was getting married to another woman, and he demanded that all the citizens in the region give him horses as a wedding present. Perseus's family could not afford a horse, nor did they have a horse to begin with. So the king said, I want you to go bring me back Medusa's head, which he assumed he would not survive from. But Perseus went on this mission, and because he is the son of Zeus, he had a lot of friends who were willing to help him. Athena gave him a bronze shield, Hades gave him a helmet that made him invisible, Hermes gifted him with a winged saddle, and another god gave him the diamond sword that he uses to decapitate Medusa. So with all of these tools in hand, he set out to go find Medusa and eventually got to the temple where Medusa and her sisters, because she's a part of 3 sisters, lived. And he snuck up on Medusa while she was sleeping. Again, a horrible thing. She's sleeping, and used the shield that was super shiny to make sure that he wasn't staring at her, because for those who know, Medusa's power was to turn anyone she looked at to stone. So he could not look at her directly. So he used the shield to reflect her reflection and used the sword to decapitate her. And he brought the head back to the king. Very sad story.
That is sad. Did the reflection make her turn to stone?
There have been other stories. With Greek and Roman mythology, there are a lot of popular stories. So some stories say that she was turned to stone and then he cut her stone head off. So that is an alternate story. But these are all stories, so they're technically true in a sense. They're all stories that people tell. So there isn't really a wrong version. There's a common version.
Is there an oldest version? Because it can get retold in different ways over the years, right?
Yeah, so there can be an oldest version.
Yeah.
And sometimes the oldest version is not the common version. It all depends on the story and how it's told. If it's because we all enjoy action and romance and all that fun stuff. So if those things are missing, then those stories don't get told as often.
Yeah.
And they tend to fizzle out.
Yeah, for sure. All right. Well, that's why Perseus here is holding Medusa's head in the depiction. And we have a special star in Medusa's head that Ricky was going to talk to us about.
Yeah, it's the star Algol that we were talking about earlier, which is sometimes called Medusa's head or the demon star. And it's kind of a really important star because it's a binary star, like we can see here. And it's really cool because it ranges in brightness from 2.1 mags all the way down to 3.4 mags, which really just means it gets 3.5 times dimmer than it is usually. This happens about every 3 days. Happens every 2.87 days, if I remember right. And then it takes about 5 hours for it to actually go from its normal brightness down to its dimmest brightness. So if you want, you can spend a whole night watching this star and see that it gets visibly dimmer and then gets back up. And this is actually going to happen. It happens about every 3 days, but it's not going to happen at nighttime until the 10th of November. But that happens at 4:20 in the morning when it gets the dimmest. So that might not be a good night. A better night would be the 13th, where you'll be able to see it get dimmest at 1 in the morning. So you could spend the whole evening watching it, and then, sunrise, it'll get back up to normal.
It gets brighter and dimmer over time. We call that
Yeah.
a variable star, and it's not like the twinkling that you see in the sky, right? So we see stars sometimes
No.
flicker in and out. It's twinkling, but this is completely different, right?
Yeah, because the twinkling is caused by the air, the atmosphere. This is actually the star is looking dimmer.
Yeah.
Because sometimes both stars are face on with us and we get all the light, and sometimes one of the stars is hiding the other one, so we don't get all the light from that second star.
Yeah, and so this is like kind of the main star here, the one that's closer to us in this illustration. So this isn't a real picture or anything. It's just a graphic that is showing what is going on at Algol. And we have the other one in the background here. So there's another star that's kind of hidden out of view. And so when these are going around each other, this one can come out in its orbit and come over here. And so when you see that area in the sky, it's going to appear as a brighter star because of that. Or is it, can you actually see it get brighter with that? Or is it just when this maybe dimmer one eclipses the other one?
It does. It gets brighter when they're both facing us, and it gets dimmer when either one is eclipsing the other.
Got it.
But one of the stars is so much smaller than the other one that one of the eclipses, or we call this the secondary eclipse, was when the smaller one is in front. It doesn't dim quite as much.
Yeah.
It dims a lot more when the smaller one is directly in front.
That's cool. So how long does it take? What's the orbital period like, or the eclipse period?
It's every 2.87 days.
Cool. Nice. Okay, so where is that in the sky? It's somewhere in Medusa's head here, right? It's right here, actually.
It's right there, right at his wrist in this picture. But some people like to say that it's the demon's eye or Medusa's eye winking.
Yeah, let's go back to the older photo of it. Let's see if I can jump there. Because this one, here it is here. But yeah, if it was just down a little bit. I wonder if they knew it when they drew this, that it was a variable star. But if they just drew it down just a little bit.
Yeah.
They might have. I know there's stories about it. I don't remember any of them, but every culture in the northern hemisphere has a different name for this star that roughly translates to demon's star. Like a lot of them have the same ideas about how it's not a good dude.
Yeah. Yeah, it's interesting.
Yeah.
All right, there's something else in Perseus, that the constellation Perseus. So when we talk about constellations, we're talking about an area in the sky. It's not just the stars that make up the picture. And so in that whole area, if you look deep into space in those dark areas or seemingly dark areas, you can see more and more if you capture the light from that area with a telescope. So using telescopes, we can see into the darkness in between the stars and discover new things like this here. So this is actually a simulation of a cluster. And a cluster of what? Well, it's actually different from some of the clusters we've talked about. It's not a star cluster. It's not a globular star cluster or an open star cluster. This is actually a galaxy cluster. Right, Ricky?
Yeah. So just like we've been talking about before, we've had open clusters of stars, just a collection of a bunch of stars. Well, this is just the same exact thing with galaxies. And it's actually a bunch of galaxies all clustered together inside of this like plasma soup of hot gas, which is what you see here, is a simulating all the gas that we see today.
Yeah, and it
So it's
looks
kinda
like they're
hard to
trying to
tell.
simulate some interactions, some gravitational interactions that are causing it. But this is the actual image. So I think they're trying to figure out how this cluster of galaxies actually became what we see today using computer simulations.
Yeah, it's pretty cool that we can do that stuff now.
Yeah.
Well, my computer can't. But
Yeah, I was just gonna ask, is like, what kind of computers can do that, and how long does it
yeah,
take
I got
those
a pretty
computers?
strong computer.
Yeah. So here's
it's not
another
that good.
image here, a real image, but it's collecting X-ray light from that area in Perseus.
Yeah, it's actually the brightest X-ray object in the sky. The Perseus cluster is.
Okay, so here it is in kind of relation to some other galaxies here. And there's also some objects with points on them. Those are stars that got in the way of this picture. Everything that doesn't have a point, though, that's another galaxy.
Yeah, it's a lot easier to see that this is a galaxy cluster in this photo than in the other one, because the other one just looks like a big cloud.
Yeah.
It's also one of the most massive objects that we see, which makes sense because it's just a big collection of galaxies.
Yeah. These ones look really large too, these galaxies here. They look like ellipticals.
Yeah.
But it might just be because of the light that it's collecting, the X-ray light. Because I'm kind of surprised that there's so many in one field of view. Because you kind of see a good mix of them, like some spiral galaxies and some other ones. I think it's because it's looking in X-ray, maybe.
It might be.
Not sure. We'll have to look that up. Or maybe Melanie knows. She can put it in the chat.
We've looked at like past pictures before where I think we were looking in globular clusters and we would see different shapes. I remember we asked the audience to look for the smudges and there were a lot of different ones. There were spiral ones and ellipticals.
Yeah.
So it's kind of weird. But that one was taken in a different, I think that was either a real picture or a different filter, so it wasn't X-ray light. It was different.
Mm-hmm. Yeah, the ones we were looked at before in the past, yeah. All right, so let's see. Do you know where in the constellation that cluster is?
Ooh, no.
No. Okay, well, the cluster is somewhere in Perseus here. But there's galaxies, really in any direction you look. But there's a large cluster that's got a pretty interesting shape in Perseus that a lot of great scientists are doing observations on. Okay, but this kind of looks the same, but this is completely different. So this is not a galaxy here. This is something called a molecular cloud or a nebula. And we've talked about nebulae a lot this series. But what exactly are we looking at here? Caleb, I think you're going to help us out here, right?
This is the object is what's known as the Perseus molecular cloud. This is it's an object that's like full of gas and dust. And this image actually here is I think it's an infrared image. And you see those two bright points right there and to the right here. I believe those are stars. This molecular cloud is basically like a stellar nursery. Newborn stars form in this cloud.
Yeah, there's little little specks here. Those are baby stars probably. And then this is light or gas that's being really lit up by those new stars being formed.
Mm-hmm.
This is a really large one. Stellar nurseries like this one, they are just so vast because, just imagine that each point here is a star. It's just huge.
Tiny ones in the background. It's really pretty.
Yeah. So it kind of looks a little spooky. We're gonna go back to the theme of Halloween here, and explore some other nebulae in space that are maybe even spookier than this one. This one's got a nice red glow. If we shift back over to see the other side of it here, it kind of looks like maybe you can draw a face here, which humans like to do, is find faces and everything. It might look like I don't know, like a fire-breathing dragon. I think it looks like a friendly elephant, but that's not really spooky. So, but we always like to find pictures and things. So let's see what else is out there that we can find pictures in. And to do that, we're going to look at some areas of the sky that are not in the constellation of Perseus. We're going to look at other regions of the sky. And the sky is just littered with these nebulae. Again, they show up in different pictures, or as different pictures or different shapes that we can draw pictures onto. Like this one here. This is another nebula out there. This is in the constellation of Orion the Hunter, and I don't want to say the name of it because I kind of want everyone watching to try to figure out what shape we see here. Astronomers always name things for what they look like, right? We have our constellations in the sky because the star patterns looked like certain objects or people or things. And then we have our nebulae like this one here that is named because it looks like a head of a popular Halloween person or creature. So if you've seen our Halloween program that we've created here at Ball State, it's up online on YouTube in 360 degrees actually. You can watch it like you are watching it inside the planetarium, since we can't host you in the planetarium this year, unfortunately, for it. Melanie's going to link to that a little bit later in the program, but you would have seen this nebula here if you've seen our Halloween program, or if you go and check it out on YouTube. And so what do we have here, friends? Caleb?
This here is what's commonly known as the Witch Head Nebula. As we said before, people often trying to find shapes in nebula, and this is a perfect example of that. It looks like what you look at. It looks like it's like the profile of a witch as seen from the side. So this is what's known as a reflection nebula. Basically, it's made out of dust that reflects light from a nearby star, Rigel, which is about, I think, the second brightest star in the constellation of Orion. So basically, the dust will basically reflect the light from Rigel, and dust often reflects more blue light than red light, so it's different from the Perseus molecular cloud.
Yeah. Yeah, so we have the witch's head. It's kind of like, here's a hat here. Maybe it's kind of drooping over to the top here. And I see an eye here for the witch head, down to the nose, and some lips, and a pointed chin. And I see like a wart on the chin. Some people say that she's screaming, so this is her open mouth here.
Oh my gosh. I didn't even see that.
I love this one. It's beautiful. It's fun. I don't know. It's got beautiful stars in it, and there's a lot of good science in it too. As Caleb said, it's a reflection nebula. It reflects blue light. It kind of like how the molecules in our atmosphere reflect blue light, causing the sky to appear blue. But this is actually a big problem for astronomers, that the blue light gets scattered in so many directions when it passes through clouds like this. It creates the light from distant objects to appear a bit red, or redder than maybe they would appear otherwise. So it's called interstellar reddening, and astronomers always have to account for dust and this when they are doing their data analysis of their observations. And I shouldn't say always, but usually when they're exploring these things or faraway things, they have to do that. But of course, when they're exploring things in our own solar system, maybe not as much, because those are pretty close to us compared to these far, far away objects like this one.
Yeah, it's a pretty big headache.
Yeah, and Melanie just put a another spooky nebula in the chat, the Black Widow Nebula. But let's check out another one. This is, well, actually, Caleb, I'll let you talk about it.
This is what's known as the Ghost Nebula. You'll see it looks like that because if you look to the left here, you see this part of the gas right here. That looks like a person is like emerging out of it. It looks kind of a shape of a not definite shapes. It looks like a ghost.
Yeah, like
So-
here too, and then even over here. Yeah.
So, like the Witchhead Nebula, this is also another Flushing Nebula. So, and this is found in the constellation of Cepheus, which, correctly, is not very far away from Perseus. So,
Yeah, we're gonna be looking at Cepheus soon in the season here. So I think either next week or the week after, we're gonna be looking at Cepheus. I think it's next week. Yeah. If you look over in the corner here, there's this kind of looks like a portal. This is a star that was just being created in this area, and it's shining through the dark dust here.
Really cool. I've never really seen dark dust like that in space.
Well,
Usually
it's hard to
very
see.
bright.
Yeah, it's hard to see because it usually just looks like empty space. So there's dark areas of the Milky Way galaxy. From our perspective, the Milky Way galaxy band that we see in our sky, or are supposed to see without light pollution, that is, anyway. There's dark areas, and it's not because there's no stars there. It's because there's dust that's blocking the starlight from reaching our eyes here on Earth.
Oh wow. Okay.
So it's hard to actually see that dust does have that big impact, because yeah, this dark area, this isn't just void of stars or anything. It's dust blocking out the starlight that's behind it, whereas some of it's thinner and we can see the starlight shine through regardless, like down here. Ricky, do you know any have you heard of bok choy, or anyone here, bok choy stars? I think that's what they're called. I think that's what this one is.
No, I haven't heard that before.
Yeah, I might be butchering the name a little bit, but usually I don't mention it because we don't go into too much detail. We don't have time to go into too much detail about that. But with this series, the Constellation crew, we can go into a lot more detail than what we've been able to in some of our programming. So it's really great.
So what is a bok choy star then?
I think it's just a new star. It's a
It's
type
just
of
like
new
a baby star?
Yeah, it's like a T
Oh, it's a new
like a
type?
T-Tauri.
That's-
No, like a new, newly formed, or T-Tauri. Like, I don't know. There's different types of newly formed stars.
Is it like a different stage and like a protostar?
I don't know. I might just be remembering it completely wrong. I think it might just be a food that I know of. I don't
Well,
know.
I know bok choy is a food,
Yeah, I was gonna say.
I know,
sounds
yeah.
like-
I was like,
but I think this is a question for Professor Google.
yeah, I would agree. Oh, so the Ghost Nebula. I'll look it up while Caleb, you explain what we're looking at here. So I don't know if everyone watching wants to try to find imagery in this other nebula here, but Ricky's got some details on it.
all right. So,
think Caleb knows more
Yeah.
than me.
Sorry, I wasn't sure what started. So
You know, I said
this
Ricky, and
is
then I said Caleb, and I think I went back to Ricky again. Sorry, friends.
so
Caleb, go ahead.
for those of you who are watching who, like me, are big fans of Harry Potter, this nebula is so gloriously named the Death Eater Nebula. Which, if you've probably seen the films, this kind of looks like a Death Eater, flying to the sky with the front, the portion at the left looking like the mask of a Death Eater. So it's also known as other call it like a Grim Reaper. So if you look up to the middle to the upper blue portion right here, you see what looks like an eye, which is one of the stars.
This one?
Yeah, right there. So it looks like an eye. Look like it has a face. So this nebula is instead of being a reflection nebula like the previous two, it's what's known as a planetary nebula, which, as we've discussed on the Constellation crew before, is the remnant of a star that's reached the end of its lifetime. So this is the remnant of gas and dust left behind. So
Nice.
Looks like a screaming Pac-Man to me, but
Like
does,
this
yeah,
is
I
the
can see that.
mouth.
yeah.
Yeah.
that's the mouth.
There's maybe an eye here with the eyeball here.
Yeah.
It's facing the other way. It's facing to the left. All right, I gotta go correct
Yeah.
myself because I was half right and half remembering just food. I think I'm just hungry for dinner or something. But a Bach globule is a dark area, an isolated area of a nebula. So it's a really dark region where star formation is taking place. So you can see that it's really dark here, and that's the Bach globule.
Okay, yeah,
and
that
then
makes
the
sense.
star is forming out of it here. So I got the
Okay,
first
and then
part
when the
right.
stars,
Yeah.
when they like turn on, they'll start
Yeah.
growing.
Yeah.
You must be really
dust
hungry.
away to be able to see them.
Yeah.
You must be really hungry to call it a bok choy nebula.
Let's just
I'm
move
with you
on.
on
I am
that. I'm
I am
Yeah.
embarrassed.
Never happened.
This
Okay.
never happened. This is not recorded in Facebook Live or anything. Yeah.
Yeah, no,
All right. So this one is a surprise. What do we think this one looks like? Surprise to the crew here. The crew hasn't seen this before right now.
This looks like those glowing fungus that you see in videos all the time where they glow at nighttime, and when you step on them, they glow. as a
Oh
reaction.
yeah. There's a Bob's Burgers
I s-
episode
I
about
see, like-
that. I think, right?
I see like a scream. I see like the screaming alien in this thing.
Yeah.
It kind of reminds me.
There's
The
the
face,
mouth here.
the face kind of reminds me of that one character from Avengers Endgame with who Tony Stark calls Squidward.
Oh, I was thinking the screen painting, but that works too.
Or like the Scream movie. Yeah. Ricky,
that
we
too,
lost
yeah.
your video again. There it is. Okay. So this
Huh.
is another nebula in space. It's a part of the Veal Nebula. So it's just another glowing cloud of gas and dust in space. It's ionized gas, if you want to be really scientific. So it's glowing, it's ionized. And it's in the constellation of Cygnus, this one. And we're looking at it in UV light here. So that's why all those stars kind of look blue. This is what we refer to sometimes as false color, because this isn't light that you would just see with your eyes, or you could just take a regular picture of in the sky. This is a special filter that's filtering it so that UV light is reaching the sensor in the camera, and we're depicting it all. Our scientists depict it all in blue here. But I thought it was pretty spooky. Threw it in here. Melanie put a link to some of the spooky nebulae out in space that came out with a Sky and Telescope article in the chat. So if you want to see more, I don't think they have this one in it though. And I don't know if they have the next one in it either. But it's one of my favorites that we don't often get to talk about. It's called the Pencil Nebula, but it also looks like something else that's kind of spooky that relates to the first nebula we saw here tonight. Well, the second one, technically.
I don't see anything, but that's just me.
It's an object, not a person.
Oh,
Oh,
I go broom.
A broom.
Is it a quill?
It's a broom. It's a witch's broom.
Oh, that's cool.
Oh.
Yeah.
I was thinking.
So here's the kind of the handle here, and then here's the broom part.
Oh, okay. Yeah.
Yeah.
May not be the
Jennifer thought it
Nimbus
was
2000, but it's really cool. Why the stars almost look round? What was that about?
Well, let's go back. Oops, sorry about that, friends.
Yeah, like in the lower parts, they have the spikes that they normally have, but then
That's a good
There's a-
question. I don't usually see that feature.
They might be oversaturated.
I
Oh.
don't know, because usually when it's
No.
oversaturated, you get bleeding, and it looks like one really, really bright, like
Yeah.
like a row in the CCD chip. Yeah, someone got that it was a witch's broom. That's good.
oh, nice. Yeah. Just
Alright.
spooky stuff.
Yeah, I don't know what the little halos are. And it's interesting that some of these have more diffraction spikes than others. These have 4, which happen when you have a certain number of arms in the telescope holding the mirror in place, a secondary mirror. But these ones look like they have 6.
Yeah. I wonder if it's a composite of a couple
Yeah.
from a couple different telescopes.
Mm-hmm.
Maybe that might be causing that.
It's interesting though. Yeah, so those watching trying to follow along here. So sometimes stars will appear to have these spikes in the pictures just because of the mechanics of a telescope, how a telescope is structured. You have to have 2 mirrors, and one of the mirror has to be held in place so that it can let light through to collect the light to observe the things that we're trying to see in space. But it has to also stay in place, so it has to have these arms, these metal arms or any type of material really, but these arms that hold it in place, and when the light passes by those arms, it gets some interference from it, and it creates these spikes here that you sometimes see in pictures. But usually it's pretty uniform, but so this might be like two different observations pieced together, which is interesting.
Yeah.
Okay, so we have a witch's broom, we have a witch head, we have the Black Widow Nebula that Melanie linked to in the chat, and we have more that you can see at the Sky and Telescope link that Mel put in the chat too. All right, we got one last Halloween themed thing to see here. Not necessarily in Perseus, but still pretty cute. They're pumpkin stars. What are these like, Nicolette?
Okay, so I'm trying to think of a good analogy, but I'll just ask the simple question. What do you guys would think would happen to a star if it was spinning very quickly? And I'm talking really fast.
It'll squash.
Yeah. Coincidentally, pumpkin squash. So that's what's happening here. This star in the visual here is spinning so fast that it's getting squished into a pumpkin shape.
Yeah, our aspect ratio is fine. Like, I didn't put the video in here wrong. I didn't squish it or anything like that. This is actually showing, yeah.
Someone like me would think that. Anyway, so yes, it is. When it spins very quickly, it turns into this pumpkin shape. There's not very much known about these stars. Most astronomers theorize that the reason why this happens is because a binary star system of 2 sun-like stars, so in size and temperature roughly the same, give or take a few degrees in radii, they are orbiting each other and eventually merge into one star. And this merge causes it to become one, but also spin very rapidly. And then it gives you this squished shape. But the fast rotation also contributes to highly active solar activity, so more solar flares, more sunspots, and other such, and X-ray emissions than our average sun-like star since it's spinning so rapidly.
Wow. A lot going on there. Why does it... So how large are they? Do you know?
They come in many different, I don't want to say drastically different sizes, but since they're sun-like stars, it really all depends on how big the stars were, and then you kind of just combine it, but I'm not exactly sure what the biggest one is.
Okay. I thought I remember that clip being a K-type star, which is not what our sun is.
Oh, yeah. Okay.
So,
that makes sense.
But yeah, so like a little different. But I'm wondering like what the mass might be. Just like how do they get spinning so fast in the first place? I guess it just has to do with maybe the formation of it and maybe the shock wave of a supernova that kind of put the molecular cloud that it was forming into motion to create it. And so maybe if it was closer to that powerful event, it could have that angular momentum to make it spin so fast. But I'm not sure about pumpkin stars. I haven't looked up a great deal into pumpkin stars.
Well, you're not alone. Astronomers are kind of confused. There's not many of them, and that's part of the problem. In astronomy, you need more than just one example in order to really understand what's going on.
Yeah.
And I think they've only discovered 18 so far in the sky of pumpkin stars, so they're having a hard time trying to figure out what's going on. 18 seems like a lot for those who are listening, but it's space is very big.
We have about 500 billion stars in our Milky Way galaxy, so 18 out of 500 billion is not a lot. So, but yeah, like with any science, you always need as many examples and as much data as you can get, and it's hard sometimes, so you have to do your best to make your predictions with what you have. All right, so let's wrap it up here. We had an exploration of Perseus here today, a constellation in the northeast after sunset this time of the year. And it's right below a popular constellation, Cassiopeia, which looks like a 3 here in the sky. Sometimes it looks like a W if you kind of tilt your head. Sometimes it looks like an M in the sky. Sometimes it looks like E. But tonight, after sunset, looks like a 3. Underneath it is Perseus. We have the bright star. Help us out again, Ricky. What star is this one?
Oh, that's Meerkat.
Meerkat?
Yes.
Meerkat?
I think that's how you pronounce it. It might be a bastardization of it.
So it's like meerkat, but calf.
With an F.
With an F. So it's like a meerkat and a calf together. Meerkat. I want to remember it now. So underneath Cassiopeia, we have Meerkat, and we have Algol off here by his wrist.
No, I'm sorry. Meerkat.
Meerkat. I'm never going to remember it now.
Yeah. I knew something was up.
You're saying it wrong.
All right. Well, at least I wasn't the one who made the mistake at the end. What is it again? I'm sorry.
Meerkat.
Okay. I don't have a clever way of remembering that one. So Meerkat and then Algol here. But anyway, if you have trouble finding the constellations in the sky, we have a star map or sky chart that Melanie's going to put in the chat for you all. So you can print it out or bring it up on your phone and check out the sky. It's one of our favorites because it's really easy to use. There's also applications that you can get for your phone that will give you a tour of the sky. It'll kind of connect to your camera or your compass on your phone and show you what's up, literally. But if that's too much trouble, just look for the moon in the sky tomorrow because it is a monthly blue moon.